So when we started out using cavity ring down spectroscopy, that was 5-6 years ago, there was a lot of attention on ammonia, especially here in Denmark. The climate agenda and the greenhouse gas emission had not at that time sort of reached the attention that it has now. We started measuring ammonia because that was what we were sort of required to do. Things really took off with the greenhouse gas emissions, and there's a huge interest now. So, but still also in ammonia, and all the sources that we're measuring to various degrees, we will see emissions of ammonia and methane and nitrous oxide at the same time. Those are really the key compounds that we are targeting. So we could see that there was this opportunity to have instruments that could measure all these at the same time. So that's really what sparked that interest. And it's just, well, it's a lot easier, and you could say also maybe cheaper to only need to bring one instrument to the field and obtain a lot of data. So we have done some comparisons. We haven't seen anything that could cause concern that the dedicated ammonia instrument was performing better than the multi-species instrument. It's something that we are, of course, paying attention to, both in terms of specificity and response time and sensitivity. It looks and also cross interferences. It looks like it's very comparable. Sort of traditional way of measuring ammonia is to collect ammonia in so-called impinges, where we have an acidic aqueous solution, and then air is drawn through the solution, and ammonia is captured as ammonium, and then the aqueous solution is then analyzed for the content of ammonium by a spectroscopic method. And this is a labor-intensive method. It is also we need to sample over several hours or maybe even full days. We need to change these impinges frequently. So in order to measure emissions from complex source, such as a livestock barn, cattle barn, for example, we need a lot of these impinges, and we need to change them frequently. We do not achieve the time resolutions that we would like to have. Let's say very widely accepted method. It is also used as a reference method, so it's good for comparison, but we can achieve data of better quality with higher time resolution, let's say less manual work, by using an online cavity ring down. There is an interest in measuring more frequently, and at least measuring at many more sources. We are limited by the access to instruments, and it takes time. So there is an interest in developing what we can call low-cost sensors that we can, easily set up near the source. In principle, we could continuously measure emissions, and then the individual farm would be regulated based on the actual measured emissions. I would say that is a very ambitious goal and probably not realistic. But we have looked in that direction and tried to develop some sensors. And we have published one example of a fluorescence-based sensor. I would say it is a bit far from something that can be commercially available, but the interest is there. But it will take quite some time before we see sort of a little box you can put up, and then you just have measurement data. And one of the challenges, of course, also is that things need to be reliable, documented, and calibrated, and be independent if it's part of a regulation system. So it is not as straightforward as some might think. I mostly know a bit about how it is done in Denmark, and so the industry, in this case, it's the agricultural industry, is regulated based on their emissions. It means that if you want to build a new farm, for example, with livestock, you need an environmental permission, and that environmental permission will sort of dictate, how large your production is allowed to be, how many animals, how large buildings, and so on. So that is regulated based on an assumption that we know what the emissions are. And of course, we do have some data on this, but we need more data. So right now, these emissions are based on what we call standard numbers. So based on some emissions measurements and maybe also some modeling, we have standard numbers for how much a certain facility will emit. In the end, the permission depends on the location also, but that's how it's regulated. The production development is very much depending on the emissions of ammonia, especially ammonia. And in the future, we will see that the greenhouse gas emissions will become increasingly important in this. I mean, you have a certain emission that is allowed, and if you want to build a production that exceeds that, then you can, of course, introduce technologies to reduce emissions. So we have a system for documenting and approving emission mitigation technologies. It's called a technology list. And technologies need to be tested according to protocol to be accepted on this list with a specific mitigation efficiency. It could be an air cleaner, for example, that can remove 80% of the ammonia. That needs to be tested, and this is done by independent test organizations. So the manufacturer of a technology who wants to sell this, he needs to go to a test organization and ask them to do a test. And that takes quite some time and will be tested on different locations. And in the end, they do the whole analysis and they come up with a certain number. Okay, this air cleaner has an efficiency of 80%, for example. We have an expert committee that I'm also part of that assesses if the test has been done according to the protocol with acceptable quality. And in the end, it's the Environmental Protection Agency that sort of organizes this, but it's actually down to the local municipalities to give the permission to the individual farmer.